You ever look at a line of Python code and it just looks like a cryptic message? Well, what if I told you it's actually just a sentence made up of different kinds of words? Today, we're going to break down those words, what programmers call tokens, and understanding them is pretty much the key to unlocking Python. So let's start with a big question. How does a computer actually read our code? It's not some kind of magic, right? The computer basically acts like a really literal translator. It has to break down our instructions into the smallest, most meaningful little pieces it can possibly understand. And those tiny units, well, they're the key to everything. Think about how we read English. A sentence like Ravi eats an apple is just made up of individual words. It's the exact same idea in Python. A line of code is built from its own special set of words. And figuring out what those words are is the whole point of this. And in the world of Python, these words have a name. They're called tokens. A token is the absolute smallest piece of your code that has any meaning. You can't break it down any further. They're the basic building blocks of every single Python program. And trust me, knowing this stuff is going to help you figure out why your code works, or more importantly, why it doesn't. Now, the good news is you don't have to memorize a million different things. In Python, pretty much everything you'll ever write falls into just 5 main categories of tokens. So let's walk through each one, and I promise your code will stop looking like a jumble of random symbols and start looking like a real language. All right, let's kick things off with our first 2 types of tokens. Think of these as the rules of the game and the actions you can take. We're talking about keywords, which set the rules, and operators, which are the symbols that actually perform actions. Okay, so first up, we have keywords. These are like these sacred, reserved words of Python. They're already built into the language, and they have a very specific, unchangeable meaning. You can't mess with them. Their job is to control the flow and structure of your program. I guarantee you've seen these all over the place. Words like if, for, while, even true and false. When Python sees one of these, it knows exactly what's up. You can't use these words to name a variable or anything else, because their job is already set in stone. You know, a really good way to think about this is traffic lights. A red light means stop, a green light means go, period. You can't just decide one day that red means go faster. It's the same with Python keywords like if or for. Their meaning is totally fixed and you have to obey it. All right, so if keywords are the rules, what are the action words? Well, that's where operators come in. These are the symbols that actually do stuff. They tell Python to perform a calculation, make a comparison, assign a value, you name it. I mean, you know these already, right? The plus sign is an operator that tells Python to add. The asterisk tells it to multiply. And that single equal sign, that's the operator for assigning a value to a variable. They are super simple, direct instructions. Honestly, the easiest way to get this is just to think of them like the symbols from math class. You see a plus sign, you add. Simple. When Python sees that symbol, it knows to perform that action. They are the verbs of your code. Okay, so we've got the rules, that's keywords, and the actions, that's operators. But what about the actual stuff we're working with, the data? Well, that brings us to our next pair of tokens. Identifiers, which are the names we give to things, and literals, which are the things themselves. So what exactly is an identifier? Simple. It's any name that we, the programmers, make up. Anytime you create a variable or a function, you give it a name so you can find it again later. That name you just created, that's an identifier. It's how we label everything and keep our code organized. Now, you can't just name them anything you want. There are a couple of super simple rules to follow. They have to start with a letter or an underscore, never a number. And they can't have spaces or be one of those special keywords we just talked about. So user underscore age is perfectly fine, but first underscore or username will definitely give you an error. Here's a perfect way to picture this. Think of an identifier like a label you stick on a storage box. If the label says sugar, you know exactly what's inside. It's the same in Python. If you have a variable named age, you're telling everyone, hey, this is where the age value is stored. Okay, this next part is so important. If the identifier is the label on the box, the literal is the actual stuff inside the box. It's the raw, fixed data value that you've typed directly into your program. So the number 18, that's a literal. The text hello, written in quotes, that's a literal. The value true, yep, also a literal. These aren't just names for something. They are the something. They're the actual values themselves. So let's nail this down. The identifier is the label, maybe my favorite book. The literal is the actual tangible book inside that box. Getting this difference, the label versus the thing, is honestly a game changer for understanding how data actually works in your code. All right, we're on to our last type of token, and this one's super easy to get. They're called separators, but really you can just think of them as the punctuation for your Python code. We're talking about things like commas, colons, and all the different kinds of brackets. They don't really represent data or perform actions on their own, but they provide all the structure. A comma separates items, a colon kicks off a new block of code, and square brackets tell Python you're making a list. They keep everything organized. I mean, imagine trying to read a book with no periods or commas. It'd be a disaster, right? You wouldn't know where one thought ends and the next one begins. That's exactly what separators do for Python. They provide clarity and structure so everything doesn't just turn into a big mess. Okay, so that's all 5. We've got keywords, operators, identifiers, literals, and separators. Now for the fun part. Let's put it all together and actually watch how they form a real, meaningful instruction that Python can understand. Okay, check out this super simple line of code. First, fruits. What is that? Well, it's a name we made up, so it's an identifier. Next, the equal sign. That's doing something, right? It's assigning a value, so it's an operator. Then you have the square brackets. Those are just organizing things, so they're separators. And finally, apple. That's the actual data, so it's a literal. See how that works? Every single piece has a job. And really, that's what this is all about. Once you start seeing code not as one big, scary thing, but as a collection of these 5 simple pieces, it all starts to click. You start to understand the grammar. Seriously, if you can get your head around tokens, the rest of your Python journey is going to be so much easier.